Okay, here are questions number 12, 13, and 14 on the web assign. Number 12 is pretty easy. It's, does this series converge absolutely, conditionally, or diverge? So the absolute value of this series is this. We'll do this really quickly. We know that this diverges because you can compare it with the limit comparison test to this divergent P series. So we know the absolute value converges. The next thing so now we're going to run the alternating series test on it. So if we look at this as an alternating series and not the absolute value, the limit as n goes to infinity is 0. So that's the first condition for the alternating series to converge. The second condition is that the n plus first term, which would be the root of n plus 5, is less than the nth term, which is the root of n plus 4. That's also true. So this actual alternating series test converges while its absolute value diverges. Thus, the convergence is conditional. So now, next one. Approximate the sum of this series by using the first 6 terms. So the first thing here is we have to figure out what is the sum of the first 6 terms. Be very careful here because you're starting at n equals 0. So you're not going up to 6, you're going up to 5. That would be the first 6 terms. Now, you're going to have to grab your calculator. I did this. I have it in my calculator right now. Hopefully it's right. And I got 22 over 15. That's the sum of the first 6 terms. So the actual sum of the series is going to be between it will only be off as much as the next term in the series, which would be where n equals 6. So this is basically what you have. So we're going to quickly calculate that. Hold on a second. I always have trouble finding my factorial for some reason. Whoa. And now I screwed something else up, so I have to. All right, so I think I got it now. So that's 1.4611. And then this one, I'm just going to change it to a plus. So this will be easy. Plus 1.4722. So that's what the actual sum is, somewhere between those two numbers. So it gives us a pretty good idea. So that's it. Then the last problem, number 14, is the same deal. We're going to use the first 6 terms again. So, but this time we're starting at n equals 1. So the first 6 terms would be this. I'm going to now type this in. So I have an x up there now. All right, hold on a second. I'm screwing up this calculator, of course. So we're going from now 1 to 6. And it's n. All right, so I think I have this plugged in. Sorry, you can't see what I'm doing. 3 to the So hopefully I plugged this in right. I'm a little nervous right now, but here we go. This sum turned out to be for me 5 over 27. So the sum will be somewhere between 5 over 27 minus, now the next term is the seventh term. So that's what I'm going to do. So when I add this to 7 over 3 to the 7th, I get the upper bound, which is 0.1883. And then when I subtract it, I'm getting a lower bound as 0.1819. Now, unfortunately, I think those are wrong. So I'm not going to do this video again. So what I want you to do is, if you're watching this, tell me what I did wrong. It's probably just a calculator mistake, but I can't wait to hear it. So thanks for watching. If you, go back to the last one if you want a better example. And I will see you on the next video.